Batteries for solar have come a long way in the last few years, and I've tested a bunch on this channel. Today, we have a brand new pallet from Discover Battery. Now, I've reviewed a lot of batteries on my channel in the past, including these gray ones from Discover Battery, and my review on those is on my channel, but bottom line, they are built like a tank, which is why I'm so excited to test Discover Battery's brand new version, which is a server rack style battery, which is more common to other ones like these that I've reviewed on my channel in the past. But there's a couple of unique features in these that I'm looking forward to testing out on this video. So here we go. Hi everybody, I'm David and welcome to my channel where I'm on a mission to take my house and garage off-grid. Hi everybody, Future David here. I realized during the editing that this is a very long video, so I will leave timestamps and chapter breaks in the description below. We're going to begin with an unboxing and look inside one of the batteries and check out how it's built. Then we'll set that battery on the workbench and we'll do some testing. First, we'll do a continuous current test, a capacity test, an overcurrent test, and then we'll test its self-heating functions. So if you have this outside and below freezing temperatures, it's still okay. Then we'll do an unboxing and look inside of the cabinet, see how the cabinet itself is built, then assemble all the batteries and wires together. We'll take a look at the communication device if you want to set up closed loop communication with the inverters. Then we'll do a current test on the cabinet and see how well it can handle its full rated current. All put together and finished and wrapped up. So I hope you guys stick around and enjoy the video. Today we have a brand new option from Discover Battery. This is the cabinet and batteries here on the pallet. We're about to break into them and test them out. With the plastic off, we have a little bit better view of this. The big tall box is going to be our server rack that's going to hold the batteries. Each battery is a 100 amp hour 51.2 volt battery, lithium iron phosphate, a little over 30 kilowatt hours of storage. Then we have a link to communication device. That's for closed loop communication with inverters. And this one is not marked, but I think this is the large circuit breaker for overcurrent protection for the wires leaving the cabinet to go to the inverters. Let's check out one of these batteries. We open it up, we have our manual. Looks like we have a communication cable. That yellow one might be a grounding wire. And we've got the nuts and screws to go into those square holes for server racks. This feels a little bit lighter than some of the other rack mount batteries that I've looked at. All right, so we have our Amphenol connectors, negative, positive. They're both on the same side in this case. We have a nice circuit breaker, power switch. You hear that thunk? That means that it's probably not MOSFETs. It's probably either a relay or a solid state relay inside. So when we take it apart, let's take a look. It also looks a little bit shorter in height compared to some of the more popular ones. And here's the model number. This is the heated model. So let's get this open, take a closer look. All right, so it looks like we have a slightly different design. In the past, some of the batteries that I've looked at, the cells are standing vertical, and in this case, we can see they're laying down flat. That's probably a temperature sensor right there. There's our circuit breaker. And a different looking BMS than usual. Usually we see rows and rows of MOSFETs, similar to these, lined up. But in this case, looks like we have a couple of relays. Let's try to get a closer look at that. 200 amp relays and 12 volts. So inside the battery, we can see the cells. There's 4 stacks, 4 cells in each stack. So we have 16 cells total. This is one cell and it's laying flat, and the terminals would be over here. And same with this one. These little orange tabs, those are the silicone heating pads going in the middle. So every single cell is actually in contact with one heating pad. So I really like that feature. The construction overall is very solidly built. I love that all these bus bars from like the negative post of the circuit breaker to the negative post coming out. That's a preformed bus bar, same on the positive side. The circuit breaker is switching on and off both the positive and negative. We have another flexible bus bar over here. That's very nice to see. And this BMS is really something to behold. We have two large relays right here. We have the shunt down there to measure the current and amp hours flowing in and out. Really nice setup. Here we go. It actually says Discover Energy right there on it. So the fact that it actually says Discover on there, I mean, this is not a generic BMS. This one is purpose built, which is very, very nice. So I'm going to borrow a couple of cables off the cabinet. So I just unscrewed this from the bus bar because the battery has this unique Amphenol connector, which is actually really great for the situation that it's in. But I need to test this on the workbench. So I'm just going to borrow one of the cables. That way I have a ring terminal on the end that I can work with. I am preparing this battery over on my workbench for the capacity test. So let's get these Amphenol connectors attached, and they're pretty cool because we just plug them in. There we go, click it on. It can rotate, but it can't pull off, not unless you press the little button on the side. And that just turned on our smart shunt. So we have the Victron smart shunt over here inside this plastic box. That's connected through Bluetooth to the app. And I'll have to reset this after we reach 100%. So I've got the cables coming out from here. One cable comes over into the smart shunt, and then both the positive and negative go to this bus bar. That's all this is, just a fancy bus bar. We've got our charger connected here, and we've got our inverter connected here for our loads. So we're going to go ahead and turn on our charger and start charging it up, and I'll catch you back after the battery is at 100%. I just finished charging this battery. It is fully charged and ready to go, sitting at 100%, and I reset the history so we're all at zeros. Now if we come over here and check out the specifications in the manual, maximum discharge current for 1 hour, we have 95 amps. So let's try that. So we'll come over here and turn on the inverter. And now the inverter is going to turn on, and we can go ahead and start this. I'm currently discharging, and I've got a heater over here running. It's that big space heater. And that's why we can see that we're now pulling 95 amps. Well, we made it. 1 hour of continuously running at just under, now we're at 94 amps, so it's fluctuated between 92 and 94 amps, keeping us below the 95 amp rating. All right, we are fully charged and ready for our next test. This will be the capacity test. We're at 100% state of charge, and I zeroed out the history. Now for the capacity test, we want to have a C5 rate, meaning 1/5 the total amp hours. So in this case, this battery is 100 amp hours, so we want 1/5 of that, or 20 amps. So it will take 5 hours to discharge. So we're going to try to get as close as we can to a constant current of 20 amps. So when I first turn this on, I'm looking for a little bit under, because as the voltage drops, we're going to go a little bit higher. Instead of using this 240 volt inverter, I hooked up this 55-gallon drum. This is a big load bank that I made. Those are all the water heaters, but we're just going to start turning some of these things on. So if I turn on those two water heating elements, let's check back and see what our discharge current is. So as you can see, those two are 62 amps, so that's a bit too high. So we're going to make some adjustments. So turn those off, and if I turn on just this one, you can see 4.7. Turn on over here. There we go. So we'll probably try that. We're at 20.6 amps with that combination, and we'll turn on the timer and catch back with you later. 4 hours and 52 minute update. We are almost done. 49.3 volts, still going a little under 20 amps at this point. And history, we've discharged 100 amp hours and 5.2 kilowatt hours. So we have passed the rating of 5.12 kilowatt hours we've hit 5.2. So we've already hit our requirements, 100 amp hours, 5.2, excellent. So this battery has already met its specifications at just shy of 5 hours in this capacity test. And if we check out the status, we're at 0%, 49.2 volts, still discharging, little under 20 amps at this point. It was over 20 amps until just a few minutes ago when we dropped down below 50 volts. So should be done in just another few minutes. And I'll sit here and watch that so that we can capture it on camera. And by the way, since we're looking through the manual, this shows the regulatory information. So we can see the different UL classifications for this battery. There we go. And it just shut off, went to 0, disconnected. That's excellent. Really good test here. So far, this battery has been working really well. We've tested our continuous discharge at 95 amps for 1 hour. We've also tested our capacity at 5.12 kilowatt hours. So both of those, it passed. At this point, I'd like to do an overload test. It says here peak discharge current is 3 seconds at 218 amps. Now a couple of pages over, we see an overcurrent curve for the breaker. We can see that if we go to 200 amps, the breaker might trip between 0.6 and 20 seconds. Anyway, so let's try discharging it at 200 amps and see if it can handle doing it for a little bit. What's cool is the BMS inside here, the battery management system, it uses relays instead of MOSFETs. And those are 200 amp relays. So we shouldn't break anything. If this thing doesn't turn back on, if we let out the magic smoke, we know that something's wrong. But hopefully it can handle this 200 amp test without a problem. So first thing we'll do is turn on the inverter, and we'll get about 95 amps, I think it was, with just the inverter, and then we'll go over to the water tank. All right, so we got our 240 volts. So now we'll come over here and turn on the space heater. We've got about 95 amps on that. Now that the inverter is running, we're going to turn on these 3 circuit breakers, which should be another 100 amps on the battery. And we'll try to do this in real time. And it shut off. There's a flashing amber light, and we're going to find out if this will turn on automatically. So in the manual, it says for over discharge current, we have a recovery after 120 seconds. So 2 minutes, and we'll see if it does do that. At this point, we're more than 2 minutes, and it's not the BMS that tripped. The BMS is still running. It's the circuit breaker that tripped off, and so this is letting us know that the circuit breaker's off. So let's try this again with a little bit less current and see how long it takes. Okay, so now we have 95 amps. Let's turn this on. And let's try turning on just one additional circuit breaker. So now we're at 114 amps, and now it died after about 15 seconds. So now we can see we have a red light flashing, the circuit breaker is still on, so now there should be a 2-minute recovery time. Well, good news, the BMS turned itself back on after 2 minutes, and nothing seems to be broken. Okay, everything's looking good. All right, we are ready for the next test. Now I took the cover off the battery because the next test is going to be testing the heating system. This battery has these silicone heating pads. They're kind of orange, and they run underneath all the cells. So every cell is in contact with a heating pad. If the battery gets too cold, it will turn on the heat. Now it can do that under a few different situations that are spelled out in the manual, but that includes under charging conditions. So I'll pull out one of these temperature sensors. I just checked with the thermal imaging, and the whole battery is nice and cool. It has sat here overnight. There we go. So there's the temperature sensor, just the very end there, and it's plugged in. So this is the one that will dip into the alcohol. So I have this cup here, and I filled this with alcohol and put it in the chest freezer. So it is very cold. Negative 20 Celsius, I think, is what was on the thermal imaging. And I'm just using this little thermal imager. It's an inexpensive one. I'll leave a link for it if anybody's interested. So let's start charging and see what happens. So the battery is supposed to turn on the heat if it is trying to charge and below freezing. It can also turn on the heat if it's not charging, but the state of charge of the battery is above 50%. So we know that the heating pads will never drain the battery below 50%. So it seems like a good scenario. Okay, so the whole system's off right now. So let's go ahead and turn it on. So we have a green light. Everything is good on the battery, and we are charging at 22 amps. So let's move on to the next thing. So now let's take the little temperature sensor and we're gonna dip it right there. And now it's gonna start showing up that it's below freezing. Oh, now we just turned to orange and red. I don't know if you saw that, but we just switched to red. And what happened is it's still charging amazingly, but we're down to 1 amp. So the BMS is restricting the current that can flow to the battery. So we have about 1 amp going into the battery from the charger. And while we're sitting here waiting, I pulled out this little amp clamp. I know the multimeter is set to voltage, but it's actually going to read amperage for us. So I'm going to clip it on the little wire leading to the silicone pad. And this is 1 decimal place off. So this is actually 1.2 amps going into the heating pad. This is showing 1.1, so it's somewhere between the two, 1.2 or 1.1 amps of current, and all of it is going to the heating pads to warm things up. So the pads don't use a whole lot of electricity. We have 4 pads, and they're using about 50 watts total, 1 amp at 48 volts or 50 volts. So we have about 50 watts total being used, and these might be sold as 12-volt silicone heating pads because I see they're wired in series with each other. So at this point we have 1 amp still being drawn, and let's pull the temperature sensor out. So now the temperature sensor is going to warm up. At this point the temperature sensor just warmed up. We now have a green light, and we are going to ramp up on the amperage. This charger is going to be about 22 amps, so we're going to get there soon. Now the battery management system sees that we are above freezing and we're safe to charge the batteries. So in the manual it actually says above 8 degrees Celsius or 46.4 Fahrenheit. And then it turns off the heating. So now the heating system is turned off and we're charging the cells at full blast. Well, this test on the heating system was a huge success. It did exactly what the manual said it was going to do. Now there's multiple temperature probes in this system. I just pulled out one, and again it's nice to see that just one sensor showing cold turns the whole system into its heating mode. So really nice job. Well, at this point I think we're done with the testing. We just did the heating, we've done overcurrent, we've done capacity, and we've done the continuous amperage test. So it passed all of the testing with flying colors. It did exactly what the manual said it was going to do. And the relays and the circuit breaker inside here are all rated for 200 amps. So when they built this, they oversized all the components. So they did a really nice job building this battery. So with all the testing out of the way, we'll charge it up, put the cover back on, and get it in the cabinet with the rest of the batteries. With the packaging off, this is surprisingly small and thin. The packaging made it look a lot bulkier than it actually is. So 6 handles, each one has a lock on it, and we have a screen and vent here, so no bugs will get in. The cabinet appears a little bit taller than me because it's sitting on a pallet, but it's about the same height. So let's check off the pallet. So 67 5/8 tall. The front here is 13 3/4, and depth is going to be 26 3/4, and then the handles will stick out another 1.5 inches or so from that. Now the other unique thing about this cabinet is outdoor rated. There's a flange all the way around the door opening and a bit of a gasket material here. So this can actually be left outside in the rain. It has a grounding point which will attach to this grounding wire inside here. We have a bunch of keys And as you can see, it's built really sturdy with lots of steel inside. So the batteries will wind up standing vertical in this one, which is a little bit unique. Most of the time they lay flat. We have a fiberglass insulating panel here. Coming down here, we have a communication port. We have nice thick bus bars. Wow, that is beefy. I'll have to get a measure on that, but that's a pretty beefy bus bar. They look like they have nylon standoffs off the back. And looks like we have our 6 wires. Each wire has its own amphenol connector on there and comes back to the bus bar. Very nice. It looks like they're all equal length wires, so we should be able to pull from the batteries equally. We have our positive wires coming down, and then I think right here is where the circuit breaker is going to wind up sitting, between that positive bus bar and that one. Something down here in the bottom, I'll pull that out and check it out. Looks like we have some communication wires as well as these steel feet that'll let you bolt it to the floor if you need to. This cardboard box was on the pallet but not inside the cabinet, so this might be a separate part number. And let's open it up. Should be the circuit breaker. 2 circuit breakers. Okay. All right, so these are 250 amp circuit breakers. It says here 250 amp circuit breaker, 125 volts DC, which is plenty because maximum charging voltage on the batteries is 58.4 volts. So we've got more than a 2 times safety factor on this. That was a quick overview of this cabinet, but the best part is that it's outdoor rated. So if we need to, we can put our batteries outside the building if we have limited space. So let's take the cabinet outside and hose it down and see how well we can keep the water out. Yay! Well, that was a light rain. Yeah, that drop was just from when I took the door off. Well, that was fun. Obviously no puddling on the inside, so let's get it back inside the garage to continue the testing. My daughter and I are standing over in the corner with the batteries, and we're about to move these gray Discover batteries. We're gonna pull them off the wall because I'd like to put this new white cabinet right here in between my DIY cabinet and the EG4 cabinet. All right, let's move over and shut off the inverters. And there's the power button, so just press the power button. Good job. And now this one, press it in and hold it for 3 seconds. There you go, now let go. See, it says off? Yeah. Good job. And we're gonna turn off the circuit breakers. Yep, go ahead and pull them down. Good, and the other one, good job. Good, step back. The ones up top were the AC voltage. And we're doing the DC side right now because we're replacing the batteries, and the batteries are DC. All right, good. We can turn this off now. So now we know there's no voltage present. So this is the socket and the ratchet. And now we're gonna, oh, you gotta kind of, here. Now push down on it. You can move your hand, push down. I bet you can do it. Use both hands and kind of push up. There you go, you got it.
I did it.
Good. This lift table I picked up from Harbor Freight. It makes easy work of stuff like this because this battery is about 200 pounds. We got the batteries all out of the way, so now I can push this cabinet into position. Inside the cabinet came packaged some of these steel L feet. And they go on here and they allow you to bolt it to the floor, which would be important if you're in a seismic zone. So I'm just going to bolt them on so that there's just a little bit more stability to the cabinet, but I'm not worried about drilling into this floor. Also, this is a radiant floor with hydronic tubing going through it, so I really don't want to mess that up. The cabinet's in place and it's looking good. At this point, I'm going to remove the bus bars and the wiring. That's going to free up the space to get the batteries in and do my knockout. Now this is a NEMA 3R cabinet, so from the factory there's no holes pre-drilled. I have to drill them as the installer. In the manual on page 17, it shows a little red diagram of where you can drill your knockouts, and it wants you to drill them in the bottom third in between these frame rails, so in this cavity here, on either side, left or right. I'm going on the left because it works out well for where my bus bars are. By putting them down low in this location, the manual says that we'll minimize any water intrusion if there was to be some. Now, clearly I'm indoors here, so I'm not worried about it being a rain-tight connection in my application, but I'm still going to follow the manual and show you how we would do it, so that if you are mounting this outside, remember you want to mount it out of the sun. So I'm in the northern hemisphere, so I would put it on the northern side of a building and probably on a concrete pad, anchoring it down. And then you could run some watertight conduit back to the building, and you might have several of these lined up going into a building where you might have your inverters. So as with most things, there's more than one way to get this done. In my situation, I'm going to be using this 2-inch 90-degree fitting. It's a liquid tight fitting, meaning that right here where this is going to go through, there's a yellow gasket, and that gasket is supposed to prevent rainwater from getting into the cabinet. So this is the fitting I'll be using, and that'll make it a tight fitting because I'm going to be putting another battery cabinet up against this one, so I don't want it coming out too far. This 90-degree fitting will keep the wires tight to the box. This piece that I'm holding is part of my hydraulic knockout kit. So I'm going to have to put this through the hole. So this is the diameter that I'm going to drill using a step bit. And this is a step bit, and I'll put a little oil on that. So this is my hydraulic knockout kit. And first we're going to start with this smaller piece and put it right through the hole that I just drilled. Then we're going to bump up to this larger diameter. Once we have the larger diameter on there, then we can use the knockout dies. We have our 2-inch 90-degree fitting on the cabinet, and the conduit's going to come this direction and then up towards those bus bars on the wall. I screwed on this piece of scrap 2x material just to give me something that I can fasten the conduit to. So this is a flexible watertight conduit, and between the fitting, the conduit, and these brackets, it was about $60 at my local electrical supply house. We're ready to start sliding the batteries into the cabinet. This is one of the very unique things about this cabinet. They tried to make a very narrow cabinet, and so the batteries will all slide in standing vertically instead of horizontally. And that makes this probably the narrowest cabinet on the market. I mean, it's really thin. So this is actually lighter than some of the other server rack batteries. Yeah. I think this one's 98 pounds, something like that. So I just slid the first battery into place, and it looks like I made a little mistake. Turns out I should have removed all these screws in advance. So I'll pull the battery back out and we'll remove all the screws. Well, I'm getting the batteries into the cabinet, and it's kind of cool how they stack up. You can see I'm putting some of these screws in place, but I can't get these top two on this battery. So I'm marking them out and I'm gonna go cut away a little bit of the metal on the ears in order to get in there. So hopefully I don't have to do that on a lot of them. I'm hoping that most of the screws just go right in, but as of right now I got 2 that I need to modify. Well, that worked out. I notched these little ears a little bit and was able to get those screws in place. Now I can continue putting in as many as I can. Like right here, I'm going to put in some more screws, but I have to leave these ones out on the outside because that's where the big bracket is going to go that holds on the bus bars. All right, well, as I stated, these 2 finally lined up, but I put them in a little prematurely. It looks like this one here needs a little bit shaved off, as well as this one and this one. So it is frustrating to do that. However, it's not the first cabinet where I've had to modify the holes to get them to fit. I had to do that also with the EG4 cabinet over there. And I don't know why that's such a thing with these. These are grounding wires for grounding the metal box of the battery to the metal frame. And every battery has a grounding screw and a corresponding grounding screw on the frame. So each battery came with one of these wires. So we're going to go and install them now before we put the bus bars in front. That'll make it a little bit easier. The manual says these need to be torqued between 7 and 8 Newton meters. So I've got 7 Newton meters on this. This little tiny M5 Phillips head stainless steel screw, I think 7 Newton meters is a lot. I can get it to 5. All the grounding wires are now in place. Up here there's 2 on this screw because this wire came with the cabinet and it's for securing to the door. But I've got all these torqued down good and tight, not to 7 Newton meters. I felt like I was going to strip out those screws, but probably to 5 Newton meters on each. So next up is going to be communication jumpers. These are 2 longer Cat 6 wires that came with the cabinet, and then there's a bunch of smaller Cat 6 wires that came one with each battery. And these are for jumping from one battery to the next. So we can do that now. So I've got the Cat 6 cables in place, and let's check our work. On page 22 in the manual, we have a little diagram. Looks like it starts at the bottom left and then comes across, up, over, up again, and then over one more time. At this point in the assembly, the manual would have me install the negative and positive bus bars. However, I think I'll install the 4-aught wires going through this conduit so that I have more space to work without hitting my knuckles on the bus bars. I'm going to do 1 pair of the 4-aught, so 1 negative, 1 positive, going through this 2-inch flex-tight conduit. It's a little bit tight when you already have the ring terminals crimped on the wires. It's easier if you do that after you fish them through the conduit. So let's get these through. So the positive wire will come over to the circuit breakers and the negative up to the negative bus bar. So once we get the bus bars in place, we'll have to finagle them a little bit better. Finally, time to install these large bus bars. And these things are really large copper bus bars. They're nickel or tin plated, really nice. Let's get a measurement on them, see how big they are. We've got 14.92 millimeters. Let's move that, get another one. 14.97. So I think we can call that 15. And this dimension, 25. These bus bars are 15 by 25 millimeters, so 375 millimeters square cross section. So definitely they can handle the 500 amps continuous that this cabinet is rated. So these bus bars are really large and beefy. So just keep that in mind when you're pricing out the cabinet. I think I saw the cabinet at about $1,900 or maybe $2,000 on another website. I was trying to find it on a few different websites. And so keep in mind that you're getting these really beefy bus bars and wiring with the waterproof cabinet as far as pricing it out and comparing it with some other options. So I just noticed that I was wondering why it wasn't falling down. The bus bar, so the bus bar assembly has these hooks on it. And it looks like that is lining up with these handles. So it'll keep it in place while you get it screwed in. That's actually really smart. The manual says these bolts should be 8 to 10 Newton meters. They're pre-torqued at the factory, but they suggested to recheck them. Also, I took off these top two when I took the battery over to the workbench to test, so I at least have to torque these ones. So let's do all of them. With all the wires torqued down, it's time for the circuit breakers. These are a separate part number. They don't come with the cabinet. These are 250 amp circuit breakers, 125 volts DC. Really nice, big, beefy circuit breakers. And I've seen these same circuit breakers used in a bunch of other applications. These, the Schneider PDP and some Midnight Solar DC disconnect boxes will also use these. So they're very popular, very good quality circuit breakers. Now they are supposed to be panel mount. So when I put the final plexiglass cover, it will secure to that as well. But the way that this one is set up, it should self-support off these bus bars because these bus bars are secured to the backing plate using nylon standoffs. Okay, so close-up of the positive bus bars. So here's the positive coming down from the batteries, and there's the space for the circuit breaker with another positive bus bar. And it looks like this one could be moved up and bolt here if you were not going to use a circuit breaker. But at least in the factory configuration, you can order a circuit breaker. You can order one or two because this battery cabinet is rated for 500 amps continuous, and this is a 250 amp circuit breaker. So if you wanted to run two, you could. I'm going to run one in my permanent setup, but I'll probably do some testing with both circuit breakers. This is the Link 2 communication device. To be clear, you do not need this. It's going to mount just above the bus bars right here. Before we install this in the cabinet, we need to change some of the jumpers on the CAN bus and then check the firmware. So in order to do that, we need to download the manuals. I will leave a link to the manual in the description below. There are two manuals that you might be tempted to use. There's another one labeled a Link 2 for Schneider manual, but it turns out that that has a little bit outdated information in it. I was comparing the two manuals and I found just a little tiny bit of differences between them, a little conflicting information. So I called Discover and they looked into it and they said this is the more up-to-date manual. So let's make sure we look at this one. And now we'll take the cover off, and inside there's some little jumpers. Right here, this is the CAN bus jumpers.
Can we touch it, Dad?
Yep. So we need to make these jumpers line up with the diagram. Yeah, so it looks like the ground is in the correct space, but the high needs to move over one. So now those jumpers are in the correct position for the Schneider. Awesome. So now we'll be able to put this cover back on. Well, things are really coming along. I think we're in the home stretch at this point. As you just saw, we had the Link 2 device. It's now mounted in place, but we reconfigured the pins on the CAN bus so that it will talk the proprietary ZAN bus network. That's what Schneider uses. You can adjust those pins so it'll talk with a dozen or more different manufacturers' protocols, whatever their, I don't know, I'm not a computer guy, their language that they're talking. So I have it set up to talk to Schneider. And then what we're going to do now is get this plexiglass cover in place. Now the plexiglass cover does two things. One, it protects us from touching the bus bars, but also it's got this little chip up here, which is something that gives us one central on-off button for all the batteries. Now I think you can use this without the link communication. So I'm going to try just turning on and off the batteries with this one push button before connecting it to the Link 2. So we'll see if that works. But first time I'm doing it, so we'll find out together. So down here on the circuit breakers, There's a couple of screws that are in there, and then there's also 2 more screws in the box that came with the circuit breakers. So we'll take these little screws out, and then we'll get this in place, and it's got the cutout for the circuit breakers right on it. That's nice. And it looks like it's going to line up pretty well with everything we have. Our plexiglass cover is in place. I really love that they built the circuit breaker spot right into it. I think that's awesome. And I also found out that the other standoffs that are behind there, that's actually if you want to use a fuse instead of the circuit breaker. Now on to the wire that'll jump from this little circuit board, which has the on-off button. I need to jump up to the battery at the end of the circuit, the data circuit. Now the manual says that I need a Cat 6 wire, and it didn't come with it, which is was a surprise to me, given that the plexiglass cover came with the case. This on-off button with the circuit breaker, it came with the case. And the case came with Cat 6 wires to help you jump between the stacks of batteries. So if they had included just one more Cat 6 wire, they could have gone from the last one over to here. But it looks like something I'm going to have to provide. I don't have any Cat 6 wire here. I do have some Cat 5e, which I'm hoping will be fine, but the manual does say I'm supposed to have a Cat 6. I should really have a 90 degree on there. 90 degree bend. All right, well, let's just see if it turns on and off all the batteries or not. It did. So all the relays in all the batteries clicked on all at the same time. And if I press it again, they all turn it off. Now, what's interesting to note is that the other end of this loop of Cat 6 cables is way down here. Is right there. And there's no termination end. It does not need one. Now these Cat 5 cables, they are temporary because they stick out a little bit too far to put the door on without causing excess strain on them. So I ordered some new ones with 90 degree fittings and they will come in. Now on the side, this says link port. So link port is what the batteries go to. And that would be the case whether you're using these batteries or the other gray batteries I used to have up on the wall. The other side, over here where it says CAN, that's the one that I configured for the inverter. So as it is right now, this is the end of the line. Now this is the charge controller, and then we have the PDP and 2 inverters. I've got the end of the line over here, and the other end of the line is the Insight Home, which is that device. So I'm going to take off this cover and get to the ZAN bus port inside here, and then I need to extend that to come over to the Link 2. Now if we come inside, this is the charge controller. The ZAN bus port has a termination on the end of it. This blue wire jumps to this charge controller, and then it jumps over to this one, and then that inverter, the second inverter, and then down to the Insight Home. And the Insight Home, which is this box right here, that is self-terminated. So all we need to do is remove this termination end, and then we'll run a new Cat 5 cable from here over to the Link 2. The manual says that this battery bank can handle 500 amps continuously. When I tested an individual battery over on the workbench, it passed all the specifications with flying colors. Now we have 6 batteries wired up in parallel in the cabinet. And I'd like to do one more test in the cabinet, and that is a continuous current test. Now I've got a couple of things hooked up here. I've got my inverter setup. These are 2 Schneider XW Pro inverters. Each one is capable of 6.8 kilowatts continuous and can surge a lot more. Now with these batteries, they can handle a huge surge, which is great because these inverters have a transformer in them, and that can also handle very large surges, which means that if you have things like air compressors and air conditioners, you don't have to put soft starts on them. this inverter can just handle them. So we're gonna just start turning things on. Once we have our load up close to 500 amps, we're gonna aim for somewhere between 450 amps and 500 amps. We're going to start the timer and see how long it can do it. Oh, something just clicked. One of these circuit breakers just tripped off right here, the one closer to me, which means everything's now going through the other one. And that's at 4 minutes in, 4 minutes and 5 seconds. Now both tripped, so everything just turned off. We recently tested this cabinet trying to get it up to the 500 amp rating, and the circuit breakers popped at 468 amps after 4 minutes and 5 seconds. After that test, I reached out to Discover Battery and was told that the cabinet was UL tested to thermal limits with 500 amps continuous, and it passed all those UL testings, but it was done with the conductors directly to the bus bars without the circuit breakers in place. Now the circuit breakers are made by a third party, that's Carling Tech, and they are also UL listed circuit breakers. It would be cool if we could get up there, and I'd like to know if I just have a bad circuit breaker or not. So I'd like to test the circuit breakers independently. Now I've got the laptop opened up with the Discover Battery software connected through USB directly to the Link system. So we'll be able to see the numbers of the battery right here. So what I'm going to do at this point, we're 100% state of charge. We are going to turn on the inverters. I'm going to turn off the solar and we'll start loading this up. So we have 94 amps. We're discharging, and let's start turning. We'll turn off one of the circuit breakers. So we're just testing one of them. This one is still on, this one's off. And we'll start turning on some of these water heaters. So the timer is running. And let's see where we're at. We're at 198 amps. So as I turn on more water heaters, 237 amps. I will have to dive into this software a little bit more. I found it very easy and simple to understand. Easy download on Windows devices, by the way, not Apple. I updated the firmware here, but I have not yet updated the firmware on all the batteries. It turns out that there are two batteries, I don't know which two, but two of them are running a newer version of the firmware than others. And that's the firmware on the BMS. Now something I'm told I can do is I should be able to update all 6 batteries in the cabinet, all at the same time with just one click on this software. Now last time the circuit breaker tripped at 4 minutes and 5 seconds. We're coming up on that mark now, 4 minutes. Let me see if the Insight Home is also showing 244 amps. That'll just be interesting. Okay, so here's the Insight Home. I logged in and we can see the battery is discharging 243.5, and this one is bouncing between 243 and 244. So that looks great. So they're both showing the same numbers. We've got one circuit breaker. We're going to try to go another 20 amps on that one. The first one, I mean, this is the one that tripped first, and it did just fine. Okay, so this one just tripped. At 6 minutes, the breaker on the right tripped. We had the same load as before, and it tripped at 6 minutes. The testing on this cabinet did not go as planned. I was hoping we could pull the full 500 amps from it, but as you can see, there are slight manufacturing differences in the circuit breakers. So one circuit breaker was tripping a little bit before its 250 amp rating, so too many amps were flowing through the other one. So this is something to keep in mind if you're going to do parallel circuit breakers, that you might have to derate the overall capacity. Now the bus bars, the wires, the batteries, we know those things can absolutely handle 500 amps continuous without any trouble. But paralleling those two separate circuit breakers will maybe trip you up. So I would suggest that if you're in a situation where you know you're going to need 500 amps on a regular basis, then maybe go with the Class T fuses in there instead, and then you can up those a little bit, maybe a pair of 300 amp Class T fuses or something along those lines in order to pull the full amperage out of this cabinet. In my situation, I'm going to be removing one of those circuit breakers and just running a single pair because I have my DIY battery cabinet in my other cabinet that I'll be paralleling in with this system. Now we are a little bit more in the future. I've actually been running this for a while, running the house, and the batteries have been working fantastic. I got the new Cat 6 wires, so let's put them in and then we'll be able to get the door on this thing. So if you remember from before, I had to run my own Cat 5 wire from the uppermost battery down to this switchboard. This will allow us to turn off all the batteries. And it also has another function I think I forgot to mention. You can wire this up to an external remote cutoff switch to kill the batteries on the outside of the building, a momentary switch. So that's pretty cool. But I had to run my own wire. So I ordered up some new Cat 6 wire, and this has the correct 90-degree fitting. It's a pair. I'll leave a link for this in the description. It's just off Amazon, and so hopefully it'll have the right 90-degree fitting so we can put the door on here and close everything up. So this package came with 2 cables. They're 3 foot in length each. One end of the cable has a straight fitting, and the other has a 90-degree fitting. One's going to be a little bit longer than we need, but it was a 2-pack. And otherwise it will work well for us. So this is currently on, and we'll see if we can do a hot swap on this. There we go. One cable from the switch to the link. And again, the link communication device is not necessary for operation of the battery. You could set this system up with voltage only. But if you have the ability to do the closed loop communication, it is a bit nicer to do that. At this point, let's get the door installed. We're going to need to hook up this grounding wire. I think the new Cat 6 wires are going to work out really well. I can see that they don't protrude past the face of the door, so the door should fit on no problem. I have the grounding wire installed for the door, and I removed the second set of 4-aught wires, the power wires. So we're going to have just one circuit breaker on because that's all I need in my system because it's paralleling with my other cabinet. So let's turn it back on. Circuit breaker's on. So I really love hearing all that go. There we go. Well, this cabinet of batteries from Discover Energy has been working excellent. I've been using it 24/7 for the last 2 months, running my house and garage off-grid. It has been working excellent. Not a single hiccup, not a single fault, no fault codes or anything like that. The closed loop communication with the inverters has just been working perfectly. I haven't had to program it because it is telling the charge controllers the maximum charge voltage, the low voltage disconnect, all that stuff. It's doing it. And I've checked both the low and high. It works great. So I haven't had any problems with this whatsoever. So is this setup right for you? Well, let's run through a couple of numbers. As it sits right here, it's about $13,000. Now that is just under $2,000 for the cabinet and then the batteries, and we have the Link 2 and 1 circuit breaker in there. So about $13,000. We have a little bit over 30 kilowatt hours of energy storage. That is a price point of just over $400 per kilowatt hour. So that is a little bit more expensive than some of the other server rack style batteries on the market. So what do you get for that? Well, you get a waterproof UL listed cabinet with UL listed batteries, and the batteries are heated. So this whole assembly is really going to shine if you mount it outside. And we've got our closed loop communication and an overcurrent protection device for the wires that join up to the inverters. That is a feature that I haven't seen on any of the other cabinets out there. Thank you everybody so much for watching, and thank you Discover Energy for sending me the battery and cabinet so that I could test it and make this video for all of you. If you enjoy the content, I really do appreciate it if you take a moment to like and subscribe and share the video with others that you think might appreciate the content. Thank you.